Hi, everybody. So, today we're going to continue our discussion of financial mathematics. Last class we did percentages. Today, those percentages will be used to talk about interest. So, today we'll talk about simple interest and some of the definitions that we'll need to talk about both simple interest and compound interest in the next video. So, any updates about things? Um, I've been a bit busy this week. I'll grade your quizzes over the weekend. I'll have practice problems on this material that I'm talking about today and the stuff I talked about on Tuesday uh, posted by the end of the day for you all to work on. And yes, so today I'll just do simple interest. I was going to do both compound and simple, but I think I'll keep this lecture a little shorter. I know the videos have been long. So let's begin. Okay. Huh. Oh, here we are. Polytopes. Apologies, everybody. Let's begin. So, today's notes. Today, we will talk about section 10.2. So, this will be a description. Description of interest definitions and types. And then, in particular, simple interest. Simple interest is, I mean, as it sounds, the most simple kind of interest to talk about. It's not necessarily the kind of interest that you're paying on your student loans or that you'll pay on a mortgage. Most interest is what we call compound interest. But I think before we talk about that, it's best to keep things simple. So let's do that. So let's start with a definition. Definition from Merriam-Webster. So interest is simply a charge for borrowed money. So I don't think I have to go too much into what interest is for you all. It's a funny thing when we take these words that we use all the time every day, and then we turn them into mathematical concepts. But for at the beginning, interest is just something. So you borrow money from someone, and when you pay interest, you're getting charged for having borrowed that money, and you will probably be charged more depending on how much money you get, more or less depending on how much money you borrow and how long you want to borrow it for. That's basically that's really the whole thing. But of course, it gets more intricate than that. So I'll say it's like a rental cost. Like a rental cost. But renting money, not a car or a house. So formally, because we'll use a lot of letters and stuff, we'll say that a lender, L, why don't I start it with if? If a lender that we'll name L lends P dollars, so P will stand for principal, I'll define that in a minute, to a borrower B, so we'll keep on using these letters for most of the chapter. Then eventually L expects to receive more than P dollars back from B. P dollars back. Sorry. Handwriting. Okay. Good. So if we'll call f, like we had f will represent the final sum of money. So if f dollars is the sum that B repays L, then the interest, which we will represent with a capital I, is going to be the final number of dollars that B repays L minus the principal amount of money that B borrowed. So, I mean, another way of writing this, which probably makes more sense to you. So, F is the initial amount that you borrow plus the interest that you have to pay is the final is exactly the final amount that you pay. Good. All right. So let's do some more definitions. It wouldn't be a normal class if I didn't start with a whole long list of definitions. So unfortunately, we're going to have to do that again. Okay. So say definition. The principal P is the sum of money that the lender lends to the borrower. Lent by L to the borrower. B. Right? So we have the principal is just the amount of money that gets lent, or that gets borrowed, depending on how you want to look at it. Good. So another definition, interest rate. The interest rate is going to be represented by little r. And this is a decimal. So the interest rate is a decimal, which is the rate that B pays to L to use that money for a specified amount of time. So really you can think of the interest rate as a decimal, which represents how much interest is added every year, or how much interest is added every month. So yes. So is a decimal. Representing the rate B pays L. Why don't I say the amount B pays L to use the principal for a specified unit of time. Okay, this will become more obvious in a minute. So the thing that you, the word that we often hear is APR. This is the term that's thrown around a lot when you hear people talking about interest rates. And so the interest rate and the APR are very closely connected. The APR is the annual percentage rate. And so this is basically the interest rate in percentage form. So a percentage of the principal added per year. So for an example of this, so maybe you get a loan that has an APR of 6%. If you get a loan with APR of 6%, then 6% of the then 6% of the principal sum of money is added in interest every year. Okay? And in this case, then if you have an APR of 6%, then your interest rate, which is usually annual, is going to be 0.06. Remember, this is just calculations like our last video lecture on percentages. So then the interest rate R equals 0.06. And so in this sense, so B pays L 0.06 times the principal amount every year. I'll put a little dollar sign there. Here, why don't I? Just to make it clear that the principal is still an amount of money. Good. Okay, so continuing on with our definitions. The term, we'll say the term or life of a loan, T, is going to be the length of time that the borrower is borrowing money. So if you get a loan that's got a 3-year term, at the end of 3 years, you better have paid your money back. So term, life of a loan, T, is the length of time that B borrows money. Okay. Another definition, our next one is going to be a repayment schedule. This is repayment schedules. Pretty self-explanatory. A repayment schedule is a schedule that you agree. Schedules agreed on by both lender and borrower for repayment of loan. And so these basically fall into 3 categories. Those 3 categories are single payment loans, these are loans which you don't pay back monthly, but you borrow some amount of money, and then at the end of the term you have to pay back the whole sum of money plus interest. And it's probably the most simple way of doing it. So B repays the entire sum, so the entire sum of principal plus interest is repaid in a lump sum at the end of the term. Okay. Alternatively, we have the more common, I suppose, depending on what kind of loans you're thinking about. Installment loans, though, are the ones that will affect your life the most at the moment, I think, with college loans and future things after that. So installment loans, these are loans which are repaid in monthly payments, paid back in monthly. Actually, do I want to be specific about them being monthly installments? Because maybe they just want to be some, yeah, monthly installments. Oh, important word to add here. Here. I'm gonna have to bring installments down there. I'm gonna have to bring monthly over there, and I'm gonna have to add the word equal. And that's important because it's the installment loans always will have you will pay the same installment. You'll have the same payment every month. Even if your interest is accumulating differently per month, you will pay in an installment loan. You always pay the same payment. Okay. Over the term. Okay, and the final kind of loan are credit card loans, which is a whole category. Whole category of loans, which is basically a little more hands-off. So in credit card loans, the repayment schedule is up to the borrower to an extent. So basically, you can pay back your credit card loans whenever, but if you pay them back later, you'll have a worse credit score. If you don't pay them on time, there are all of these other stipulations and stuff. So to an extent, your repayment schedule is up to you. Okay, so final two definitions are, the first is going to be, what is simple interest? I mean, it's the name, it's the section title, but what is it? So simple interest is when the interest rate is applied only to the principal P. Okay, so what does this mean really? Well, if so in simple interest, if your interest rate is only applied to the principal amount that you borrow, well then once you borrow the money and you know your interest rate, you know exactly how much you're going to need to pay back. Because the idea of this is that no matter how fast or slow you pay it back, the interest rate is directly applied to the principal amount, not how much you're paying back per month or how quickly you do it. So interest paid on the loan is constant. Thus, interest simple interest paid on the loan is constant. Typically, these typically simple you experience simple interest when you use single payment loans, these ones up here, where you just pay back the whole sum at the end. Because if you're doing simple interest, it doesn't really make a difference whether you do monthly payments or not. You're paying the same amount either way, and so they'll often do them as single payment loans. Typically, typically single payment because simple interest, because you would save no money. Paying it back early. So you would save no money because maybe I should say B would save no money paying it back early, and L would make no money off of early installments. Okay. And so before I start talking about some examples of simple interest, I'll just tell you the definition of compound interest so that we have a thing to compare it to. So by contrast, we have compound interest, which I'm sure you've heard the phrase interest compounded monthly, interest compounded annually, etc. And this is when the interest accumulates over the course of the term. So at the beginning, the interest is just the interest on the principal. So at first, you pay interest on the principal. Next, on your next payment, next you pay in interest on the principal plus the interest that you gained during the first term, the first installment period. So that's next you pay interest on P plus the interest that was accumulated in the first installment, in the first period. Okay, as I haven't said. So here, partial in the first, or why don't I not use the word period? So first, yeah, I'll say it, sorry. Period. Here, partial payments reduce the total amount of interest. So if you pay more early, then you'll pay less interest in total. Okay. Installment payments often required. Like if you, e.g., car loans, mortgage loans, etc. So this is when the lender will want you to pay installment payments every month, just to really to make sure that they get all of their money back, because these are much bigger sums, and people would have a lot harder time paying back a whole mortgage in one lump sum at the end. So that certainly wouldn't be one of our single payment loans. Okay, so for now, simple interest. So we need, or we have, R, which is an APR expressed in decimal form. APR expressed as a decimal. So that means that the interest rate is yearly, and we'll use the APR, the annual percentage rate, to calculate it. P is going to be our principal amount borrowed. RP is going to be the interest that we accumulate per year. RP, that is like, so if R is the interest rate and P is the principal amount, then you multiply the interest rate by the principal amount to find the amount that, the interest that accumulates every year. Interest accumulated per year. And then, that's important. And T will be the term of the loan. In years. So this is important. All of our things are in years for the moment. All right. And so if we have everything using the same units of years and dollars, or whatever currency you want to use, this will give us the simple interest formula. So the simple, I mean, we could come up with it in our heads, really. So now that we have all of this information, what do we got? If we set I to be the total interest accumulated over the term, then how are we going to calculate that? Well, if we already said that RP, when you multiply the interest rate by the principal, then what you're going to get is the interest that accumulates every year. And if the term of our loan is in years, well, we just can multiply the interest that accumulates every year by the number of years, and we'll get a formula for the total interest that we accumulate. So this is going to be T times R times P. Good. And from this, we'll note final amount paid, which is F, is going to be what? Well, the final amount paid is the principal amount that you borrowed plus the interest. So let's just do that. So it's the principal amount plus the interest. And we can simplify that because now we have a thing for now we have a formula for the interest being precisely this. Okay, so that's P plus TRP. I just write the letters next to each other instead of the multiplication sign. It means multiply. And if we want, we could factor out, notice that there's a P here and a P here, so we can factor out that term and get P times 1 plus TR to give us our final amount paid. Okay, so we're going to use these formulas quite a bit when we do some examples here. Okay, so let's do a first example. Suppose you find a credit union that will give you a student loan under simple interest. This would be ideal because simple interest, I mean, you're going to pay less on a simple interest loan simply because the interest is only being compounded based on your initial amount borrowed, not the initial amount borrowed plus the interest that's already been accumulating for months. So suppose you find a credit union which will give you a student loan with simple interest. I'll note that this is rare. Okay. And so let's say that they have an APR, an annual percentage rate. Remember, that's what that stands for. Is 6%. So what does that? I'll just remind you all what that means. If the APR is 6%, this means that 6% of P is added. Is a 6% of P is added to the interest every year. Okay? And so what does this give us? This means that, so R is, remember that we're just, R here is just the APR expressed as a decimal. So let's just do that. 0.06. Good. So we're going to be, as you can see, percentages, decimals, they play in a lot with financial math. Good. So let's say that their term is 3 years. And let's say that you borrow $5,000. So P is $5,000 borrowed. And so now the question is, how much will you repay after the term of 3 years is up? Well, let's use our formula. So remember that the final amount is going to be the principal plus the interest, and this is the principal plus R times T times the principal. Okay, remember that formula. Okay, well, so that means that F is going to be, principal is 5,000 plus the RTP, so that's 0.06 times 3 times 5,000. And so we'll go and put that into our calculator here. 0.06 times 3 times 5,000 is equal to 900. So this is 5,000 plus 900. So that's 5,900. So the total interest that you accumulated over 3 years was $900, right? Why don't I put a dollar sign there? Okay. Let's say that maybe if you say you can repay $6,000 after 3 years. How much could you have borrowed? So this is just a little bit of math practice, really. So now we need to find P. Well, if F, we remember, is P plus RTP, we can factor out that P and we get 1 plus RT. And so that means that we can write P if we just divide both sides by 1 plus RT divided by 1 plus RT, then we'll get the final thing. So P is F divided by 1 plus RT. Okay. So now if we know that our final is now 6,000, then we can just plug 6,000 in for F and put that over 1 plus, what was RT? RT was 0.06 times 3. So 0.06 times 3. This is 6,000 over 1 plus 0.18. So that's 6,000 over 1.18. And if we wanted to do that out, what would we get? 6,000 divided by, clear everything, 6,000 divided by 1.18 is equal to $5,084. $5,084.74. $5,084.75. So, well, actually, that's kind of interesting. Something funny happened here. So I'm back. I was worried there might have been a problem there, but we're all good. Everything was correct. So if you could have paid 6,000 back at the end, then how much could you have borrowed? Well, we used this formula and we found you could have borrowed $5,084. Good. If you want, it could be a fun exercise. Go and check on example 10.8 in the book. It's different. There is a slight difference between the question I asked about saying you can repay 6,000 back after 3 years and their question, which was a little different, which was saying, what if you could repay $1,000 in interest? Then how much could you take out? Subtle difference there. I'll let you look over it. But yeah, so let's move on. Or why don't I say one more situation. So if you want to pay your loan back early, check the fine print. I know this is an example. You thought we were doing math, but this is a lesson. Check the fine print. So some simple loans, allow you to pay less interest if you pay it back earlier. To pay less interest if you pay it back earlier. So in this case, we could plug it into our formula. So say you have the money after 2.5 years, then you could, provided that it's in your contract, then you could just plug 2.5 into our formula, and then you'll get the interest is going to be 5,000 times 0.06. The interest rate hasn't changed. Times 2.5, and so that's only $750. And so you went so you may be able to pay back $5,750 instead of $5,900. Like it was before. Okay, so now let's talk about some real examples of this. Like I said, so this was kind of a little bit fictitious because most places won't give you a student loan with simple interest. But things that will, so e.g. bonds. I don't know if any of you have savings bonds or bonds in general. So simple interest. So a bond is when you give your money, you become the lender. So you give your money to some agency, which is going to use that money to, I don't know, build roads if it's a government agency, do all kinds of things. They come up in lots of different circumstances. But basically, you're the lender, and you will get more money back from the agency after a certain amount of time. So, good. Let me start on these notes. These are investments. So, simple interest is used on government or corporate bonds to raise money for some agency. Okay, so basically you buy a bond, you lend your money to the agency that's issuing it, and you buy a bond. Buying a bond is when you buy a bond, you lend money to some agency. Good. Issuing. Okay. To raise money, maybe I should take this bit away. It's just to raise money. If it's a government bond, it's raising money for the government. If it's a corporate bond, it's raising money for some corporation. And in general, you're raising. It's the agency that's issuing it, which is raising money. Okay. They are defined by their terms. So that's the amount of time. 3 years, 5 years, etc. They're also defined in terms of by their APR and by their face value. This is the amount of money that you'll get back after the bond reaches maturity. Okay, so for an example of a bond, why don't we just say you buy a municipal bond. You buy a 5-year municipal bond. 5-year municipal bond with face value $1,000 and APR of 3.25%. So that's, remember, that's an APR, annual percentage rate of 3.5%. Remember that this means that R is 0.0325. Okay? Good. So now that we've got all of that information, we have the number of years in the term, the face value, which is the amount of money that you'll get back, and the APR. Well, now we can calculate how much that bond should cost. How much does the bond cost? The bond is going to, well, we can figure that out. So remember, the tricky thing is that now we've been given the face value. So careful. Here we are given F, not P. So what we're trying to do is figure out the principal, P, the amount that the bond costs, which, when you're the lender, is the amount you're giving the agency, right? So if we're given F being 1,000, And we know that f is p times 1 plus rt. So that's going to be p times 1 plus 0.0325 r times t is 5 years. Well then, if we want to find p, so p is going to be 1,000 divided by 1 plus whatever 5 times 0.0325 is. We can put that in our calculator. 5 times 0.0325 is, yeah, well I want to add 1 anyway. Well, that's 1.1625. And then if we take 1,000 divided by 1.1625, we should get 860.21. It's about, we'll round, 860.21 cents. Good. Or 22 cents, maybe. We should have rounded up. Okay. So that's our one kind of simple interest. Notice that this means that the principal and the face value will always be proportional. Notice that f and p are directly proportional, which is to say that as p increases at a constant rate, f increases at a constant rate, and vice versa. In simple interest. Okay. So I'll let you mull over that statement because it's, but the proportionality of these things is quite interesting. Okay. And so our final example is going to be our payday loans. These are kind of fun. I mean, well, not fun for the people who take them out. They're illegal in Vermont. Actually, there are 17 states which have banned payday loan companies. But first, let's figure out what they are. So these are short-term loans for small amounts, usually a max of $1,000 or so, or $1,500. Just about what you could get in a paycheck. Using a future paycheck as collateral. Okay. So you may have heard this in terms of loan sharks, right? So this is a thing to be careful of. But particularly in impoverished neighborhoods, these are really important a lot of the time. Just in general, sometimes if you just don't have the money for groceries this week, but you know that you've got a check coming in soon, you could go and at least you could eat. So there is some justification for payday loans, even if they screw people over. So basically, sometimes you're broke and you need a little advance. So of course, interest rates are higher. But how much higher? So obviously interest rates are higher. I say of course, but maybe you wouldn't have thought of course. The interest rate should be higher because those payday loan companies are taking a bigger risk on you. And they're also doing it in a much shorter amount of time. You can just go and ask directly for it, and they're just taking your word or sometimes a bit of proof that you have a paycheck coming. But it is a bigger risk for them. And they'll use that line. So good. So here's an example of how this works. So example. Say you need 400 for trip. I don't know. But you have no money. However, tax returns are coming soon. So you decide to take out a payday loan. Okay. So you go to this place called, I don't know, something like Quick Cash and Go or something. So the loan company charges $15 for every 100 lent. So the term is often much shorter, right? Because they're just waiting for your paycheck to come in. So the term is 14 days. After 2 weeks, you have to pay back your loan. So the interest, if so first, let's see. If you want to take out $400 and they charge $15 for every $100 they lend, then your interest should be 4 times $15, which gets $60, right? So if you take out a $400 loan, you're going to have to pay back $460. So maybe this isn't so bad. So you pay back $460 for a $400 loan. You might not think this is so bad, but let's calculate the annual percentage rate. And then you'll see just how shocking of a number this is compared to what real loan companies do. So let's calculate the APR. So if your interest, remember our formula, I equals PRT. And so that means that R, if we divide out by P and T, is because we want to find the APR, and so we want to find R. So that's going to be the interest divided by the principal times the amount of time. Okay, so that means that R is, the interest is $60 divided by the principal of $400 times the amount of time. Well, how do we find T? So T in years is, well, we could just do a fraction. Let's say 14 days out of 365 days in a year gives us our term of 14 365ths of a year. That's 14 over 365. So we can rewrite that as 60 over 400. And remember, divide by a fraction, we flip the fraction. Multiply by the reciprocal. So we multiply by 365 over 14. And if we do this on our calculator, which I've already done ahead of time, we're going to get 3.9107. You can check that if you want. But this is the decimal, remember. This is the decimal for our APR. So if we want to turn our decimal back into a percentage, turning this back into a percentage, we find that this is a APR, this is a 391.07% interest rate. That's enormous compared to like 6% interest rate that you see on some others. So this is enormous. Good. So note is that 17 states have banned this. Banned payday loans. Others have capped the APRs. Although capping the APR can be up to like 400%, so you're really paying a huge annual percentage rate on these. Okay, so that's simple interest, and next time we'll talk about compound interest. Okay, bye.